So we're doing more distance equals rate times time. But this time we're traveling in water. Okay? So if you're going upstream, is the water going to make you faster or slower? Slower. So you have to subtract. Okay? And if you're going downstream, is the water going to make you faster or slower? Faster, because you're going with the water, right? So we've got distance equals rate times time, and distance equals rate times time. So two different ones, two different formulas. You have to pick whether you're going upstream or downstream. And so if you're going upstream, your rate is the boat, so the speed of the boat, minus the speed of the water. So even though the speed of the boat is going upstream, you have to subtract the water because it's not helping. And then times time equals distance, okay? And if you're going downstream, the boat and the water are working together, so it's increasing your speed and you're going to go faster. So make sure you have those formulas written down. Okay. All right, so Annie and Patrice go 50 miles downstream in the same time it took them to go 30 miles upstream. If the speed of their boat was 4 miles per hour in still water, what was the speed of the current, and what were the times? So we have two different equations that we need. We can go 50 miles downstream. So downstream is with the water. So the boat plus the water times time equal to 50. And we might, I guess, put TD here for downstream. And they can go in the same time. Let's see. So we also can go 30 miles upstream. So that's against the water. Okay, so rate times time equals 30. All right, what do we know about the times based on that first sentence? Yeah, same time, right? So you can just use T. We can go ahead and take this out because our times are equal, or if you want to put TU equals TD maybe off the side, but we only need one T because they're the same. All right, the speed of their boat was 4 miles per hour in still water. So what do we plug the 4 into? B. All right, so the boat is 4. And the boat over here is 4. Same boat. What was the speed of the current, and what were their times? So we're down to two equations and two variables, the water and the time. So we can just do substitution or elimination. I recommend elimination. So first we have to distribute the T to each equation. So I have 4T plus WT equals 50. Just distribute. And then here I have 4T minus WT equals 30. And let's line them up. So I'll just rewrite this one here. And if we add down, what happens to our WT? Yeah, they're going to cancel out. So we get 8T equals 80. So what is our time? Okay, so 10 hours. All right. And then all we need to find is the W. So you can go back to either equation. I'm going to go back to this one right here. Even with the parentheses, it's actually pretty easy if you divide both sides by 10 first. Okay, so if I divide each side by 10, I have 4 plus W equals 5. So what's the speed of the water? 1. So subtract 4. Speed of the water is 1 mile per hour. Okay. So either way, it took 10 hours, and we got the speed of the water is 1 mile per hour. Let's try another one. The sloop Zolly, that's a boat, could go 33 miles downstream in 3 hours. but required 4 hours to go 12 miles upstream. What was the speed of the boat in still water? And what was the speed of the current? All right, so we can go 33 miles downstream. So is downstream with the water or against the water? All right, so the boat plus the water times the time is equal to 33. And the speed downstream. All right. And then we can go 12 miles upstream, so that's against the water. So the boat minus the water times the time upstream is equal to 12. All right, so when we went 33 miles downstream, it took 3 hours. So we can go ahead and plug in our time. And when we went upstream, it took 4 hours, so we can plug in our time. Okay, what was the speed of the boat in still water? What was the speed of the current? So we need the speed of the boat and the speed of the water. How could we make each of these problems easier instead of distributing, Kayla? Yeah, I would probably divide each side by 3, because then we just have boat plus water equals 11. And over here, what could we do? Divide by 4. So then we have boat minus water equals 3. So it's a little bit easier, and then line them up. Boat plus water equals 11. What happens to my W's? Cancel. So we have 2B equals 14. So B equals 7. So that's the speed of the boat is 7 miles per hour. Right? Plug back in. I'd probably come over here. This looks like an easy equation. So if the boat is 7 miles per hour, what's the water have to be? Good. Okay. Let's try one more. All right, the water in Flint River flows at 5 kilometers per hour. So they're giving us the speed of the water. A speedboat can go 15 kilometers upstream in the same time it takes to go 25 kilometers downstream. How fast can the boat go in still water? All right, so let's start with each of our distances. All right, so we can go 15 kilometers upstream. So upstream, is that with the boat or with the water or against the water?
Against.
All right, so that's boat minus water times time upstream is equal to 15. Okay. In the same time it takes to go 25 kilometers downstream. So downstream is with the water, so boat plus water times time downstream equals 25. All right, let's fill in some more stuff. The water in Flint River flows at 5 kilometers per hour. What do we plug that in for? W. In both equations, all right? It's the same water in the same boat.
Did you say T?
Yep, and then we're going to do that too. So same time, right? So the times are equal, so let's just take out the upstream and the downstream because we have equal T's. All right, so we're down to just the B and just the T. So now we have 2 equations and 2 variables, so we can do substitution. I would distribute on this one, right? There's nothing you can divide by to make this equation like any easier. We have to distribute. So BT minus 5T equals 15. And then let's distribute here. So I have BT plus 5T equals 25. Line them up. So I'll rewrite this one over here. So remember when we did those double variable problems recently? That was on the test, last test. Okay, good. This is why you guys learned them, basically, for these problems right here. So now my 5 T's cancel, and we're going to solve for BT. We get 2 BT when we add those equals 40. Divide by 2, so BT equals 20. We still haven't really solved for anything yet, right? So what do we need to do with BT equals 20? it into one of these. How about this one? So 20 minus 5t equals 15. Subtract the 20 from both sides. That's negative 5. Divide by negative 5, and that is 1. All right, so we found our time. So do we need to know that? Not yet. Not really. We got t, though, so we need to find the speed of the boat. So let's plug in. Where do you want to plug in? I don't know, right here. This looks like an easy place. Okay, so what's the speed of the boat? 20 kilometers per hour. Okay, 20 kilometers per hour. And that would be the speed of the boat in still water, right? Without